V.B.T. V.B.T. Valence bond theory. Valence bond theory. Okay. Valence bond theory. This theory was developed by Hitler. This theory was developed by Hitler and London in 1927. Okay, and later on extended by Pauling and Slaughter. Later. Okay, and later on extended by Pauling and Slaughter. Okay, Pauling and Slaughter. Pauling and Slaughter in 1931. According to Hitler and London. According to Hitler and London, a covalent bond results. A covalent bond results when two orbitals containing one electron of opposite spin one electron of opposite spin overlap and lead to pairing. Lead to pairing of the electrons. Okay, let us consider the bond formation in H2 molecule. Let us consider the bond formation of H2 molecules. It was two atoms. Okay, each containing one unpaired electron. Each containing one unpaired electron. It's containing one unpaired electron. Okay, with opposite spin. With opposite spin. Okay, with unpaired electron with opposite spin. H atom. Okay, so it has two atoms. Each containing one unpaired electron with opposite spin. With opposite spin. With opposite spin. Okay, when the two atoms are far apart, there is no interaction between them. There is no interaction between them. When two H atoms comes closer, when two H atoms comes closer to each other, there is interaction between them. Hence the energy decreases due to the fact that the attractive force between the nucleus of one atom and electrons of the other atom, okay, and vice versa, are stronger than the internuclear and inter-electronic repulsive forces, okay. When two H atoms comes closer, when two H atoms comes closer to each other, there is interaction between them, hence the energy decreases due to the fact that the attractive forces between the nucleus of one atom and electrons of the other atom, okay, and vice versa, are stronger than the internuclear and inter-electronic repulsive force. This lowering in potential energy continues till a critical internuclear distance occurs. At critical internuclear distance, the potential energy becomes minimum, where the value of attractive force becomes maximum. This distance is called bond length. This distance is called bond length. At this distance, the attractive and repulsive forces balance each other, and H2 molecule is formed on approaching very closer. There is repulsive between two different atoms. Okay, if the internuclear distance radius to more than bond length, if the internuclear distance, if the internuclear distance is more than bond length, the repulsive force increases and molecule becomes unstable. Repulsive force increases, repulsive force increases and molecule becomes unstable. Molecules becomes unstable, okay. If the spins of two electrons are parallel, if the spins of two molecules, if the spins of two electrons are parallel, the energy increases as two atoms comes closer, hence bond formation does not take place if the spins of two electrons are anti-parallel. If the spins of two electrons anti-parallel, only then potential energy becomes minimum. Potential energy becomes minimum. Potential energy becomes minimum, and H2 molecule is hard, and H2 molecules is formed. formed. Okay. Thus, in the formation of H2 molecules, the distance between two H atoms gradually decreases. The overlapping of electrons clouds increases and the potential energy becomes minimum. The value of attractive force becomes maximum and finally a covalent bond forms. Okay. The difference condition of energy state in the formation of H2 molecule is shown as like internuclear distance. Okay. Potential energy. This is potential energy. This is potential energy kilocalorie per mole. Kilocalorie per mole. Okay. Potential energy in kilocalorie per mole. Okay. And this is a 0 point. This is 0 point and 0. This is a 50 and this is 100. Okay. And this is 100. This is a 50 and this is 0 and this is a 50. This is a 100. Okay. Sorry, this is a 100 and this is 150. Okay. Then this is minus plus VE and this is minus VE. Okay. Then this curve is starting from here and go to here as like, and one curve is starting from here and go on as like direction. Okay. This is the curve first. This is curve first H atoms. For H atoms. Which atom? H atom in same direction. Parallel in same direction. And Leo is 0.74 angstrom and energy delta E is 104 kilocalorie per mole. Kilocalorie per mole. Okay. Kilocalorie per mole. And this is a energy difference. This is energy difference. And this is curve second. And this is a D0 and in opposite direction. Which direction? Opposite direction. Parallel to each other but anti-parallel. Which parallel? Anti-parallel. H atom, hydrogen atom. Which atom? Hydrogen atom. And here this is hydrogen atom and some overlapping hydrogen atom, and this is SH. Okay. And internuclear distance. This is the internuclear distance. This is the internuclear distance. internuclear distance. This is internuclear distance. Okay. Potential energy curve of H2 molecules. This is potential energy curve for H2 molecules. H2 molecules. Okay. H2 molecules. And next curve of first and second show the energy changes in case of parallel and anti-parallel spins of electrons. Curve of first and curve second show the energy change in case of parallel and anti-parallel spins of electrons up to H atoms respectively. The curve second shows that the curve second shows that when atoms having opposite electrons spin, comes closer their energy decreases, and if the distance between them reduces further, the energy begins to increase for H2 molecules. The bond distance is 0.74 angstrom. Okay. The bond distance is 0.74 angstrom. If the internuclear distance decreases to more than 0.74 angstrom, a repulsive force is developed and the H2 molecule becomes unstable. The potential energy or binding energy corresponding to bond distance 0.74 angstrom is found to be 4.52 electron volt. Which electron volt? 4.52 electron volt or 104 kilocalorie per mole. Or 436 kilojoule per mole. The curve first show that if the spins of unpaired electron are parallel, then they will repel each other, and two atoms will never come closer together, and no bond will be formed. At 0.74 angstrom, each hydrogen molecule attracts not only its own electron but also the electron of another H atom. Okay, due to which bond the electrons form covalent bond and are shared by both H atoms according to orbital concept. 1s orbital of one H atom overlap with the 1s orbital of second atom to the maximum existent according to Hyder and London. A covalent bond is formed by the overlap of two orbitals each containing electron of opposite spin. Thus the essential condition for formation of covalent bond is the atoms participating in bond formation must have unpaired electron. Thus the phenomena of bond formation by overlap of orbital is known as valence bond or atomic orbital theory. Okay, atomic orbital theory. 1 minute. Atomic orbital theory. Okay, this is the atom. This is the nucleus and H atom. And the one electron move and plus. This is a HB Hb atom. Which atom? Hb atom, and this is the nucleus of Hb atom, and one electron parallel moves but anti-parallel. But anti-parallel because the direction of this is anti. Okay. So the result formed H2 atom Hab as like this. This is nucleus of each atom, and each atom is some overlapping to each other. So H A bond HV formed. This theory depends upon the pairing of electron and neutralization of their spins. Pauling and Slater developed this theory of Hitler and London to account for the directional characteristics of covalent bond. Okay, this theory depends upon this theory depends upon this theory depends upon the pairing of electrons and neutralization. The pairing of electrons and neutralization of their spins Okay. Pauling and Slater developed this theory of Hitler. Developed this theory of Hitler and London to account for the directional characteristics of covalent bonds. Okay. Important postulate of V.B.T. Important postulates of V.B.T. valence bond theory. Important postulate of V.B.T. valence bond theory. The important postulates of V.B.T. are given below. First point. The covalent bond is formed by overlapping of atomic orbitals. The covalent bond is formed by overlapping of atomic orbitals. Overlapping of atomic orbitals. Okay. The atomic orbital must contain unpaired electrons. The atomic orbitals must contain unpaired electrons. Unpaired electrons of opposite spin which are neutralized due to overlapping. which are neutralized, which are neutralized, which are neutralized, which are neutralized due to overlapping, due to overlapping, due to overlapping. Okay. The covalent bond is formed by overlapping. The covalent bond is formed by overlapping. As an example, okay. The covalent bond is formed by overlapping of atomic orbitals. The atomic orbitals must contain unpaired electrons of opposite spin, which are neutralized due to overlapping, which are neutralized due to overlapping. Okay. Second point. Atomic orbitals containing parallel spinning electrons will not overlap. Atomic orbitals containing parallel spinning electrons will not overlap as that they will repel each other. Hence the spin of both, the electrons must be opposite. Atomic orbitals containing parallel spinning electrons will not overlap, okay, as they will repel each other. Hence the spin of both the electrons must be opposite. Okay. Third point. Which point? Third point. The bonded pair of electrons is localized between the containing atoms. Okay. The containing atoms. The bond pair of electrons is localized between the containing atoms. Fourth point. The number of covalent bond bonds will be equal to the number of unpaired electrons. Will be equal to the number of unpaired electrons. Unpaired electrons present in the atomic orbitals. Present in the atomic orbitals. Okay. Example: nitrogen atom has 3 unpaired electrons in 2p3 orbits. So Two N atoms combine to form 3 bond. Two N atoms combined to 3 bond because the number of covalent bond will be the number of covalent bond will be equal to the number of unpaired electrons present in the atomic orbital. So example, nitrogen atom has 3 unpaired electrons. Nitrogen atom has 3 unpaired electrons in 2p3 orbit. So 2 N atoms combine to form 3 bonds. Okay, because the number of covalent bonds will be equal to the number of unpaired electrons. Okay, and 5 number 5. Okay, 5. The paired electrons present in the outermost shell. The paired electrons present in the outermost shell, valence shell, which are known as valence shell do not take part in chemical bond formation. Do not take part in chemical bond formation. Chemical bond formation. Such electrons form bonds only. When they can be unpaired, without the existence of expenditure of excessive energy. Okay, point number 6. As the nitrogen contains 3 unpaired electrons. Nitrogen contains 3 unpaired electrons. 2s2, 2px1, 2py1, 2pz1. Okay, and so with 3 F atoms, it forms NF3. Okay. N cannot form pentafluoride. N cannot be formed pentafluoride PF5 because there is no orbital available in the n equal to 2 level to accommodate one of the unpaired 2s electrons, and 2s square electrons remains intact with nitrogen as a lone pair, non-bonding electrons pair, due to which nitrogen does not form NF5. Okay? But P forms both PCl3, PCl5. The electronic configuration of P as a P15 as a 1s2, 2s2, 2p6, 3s2, 3px1, 3py1, 3py1, 3pz1, 3pz1, 3pz dash. Okay? Z1 and 3d0, okay? The three unpaired electrons in 3p orbitals of P combined with 3 chlorine atoms and PCl3 will be formed. In addition to this, one electrons of 3s2 are phosphorus is unpaired and enters into vacant 3d orbitals of P. So P gets 5 unpaired electrons occupying 3s1, 3px1, 3py1, 3pz1 and 3d1. Okay? These 5 orbitals overlap with 5 p orbitals of chlorine or phosphorus atoms and form PCl5. PCl5 or PF3 or PF5 molecule. Thus P can be formed tri or pentahalide. Thus P can form tri or pentahalide. Okay? And again, as N contains 3 unpaired electrons. N contains 3 unpaired electrons. Okay? 2s2, 2px1, 2py1, 2pz1, and so with 3f and so with 3f atoms it forms NF3. Okay? N cannot form pentafluoride. PF5 because there is no orbital available in the n equal to 2 level to accommodate one of the unpaired 2s electrons. Hence, 2s square electron remains intact with nitrogen as lone pair, non-bonding electron pair. Okay? Due to which nitrogen does not form NF5. Okay? But P forms both PCl3 and PCl5. The electronic configuration of P is as 1s2, 2s2, 2p6, 3s2, 3px1, 3py1 and 3pz1 and 3d0. Okay, the 3 unpaired electrons in 3p orbital of P combined with 3 chlorine atoms. Okay, and PCl will be formed. In addition to 1 electron of 3s2 or P is unpaired and enters into vacant D. Enters into vacant vacant 3D orbit of P, so P gets 5 unpaired electrons. So P gets 5 unpaired electrons occupying 3s1, 3px1, 3py1 and 3pz1 and 3d1. These 5 orbitals overlap with 5 p orbitals of chlorine or fluorine atoms and form PCl5 or PF5 molecule. Thus P can be tri or pentahalide. So Thus P can be found tri or pentahalide. Tri or pentahalide. Okay. 6 point. 6 point. The strength of the bond. The strength of the bond. The strength of the bond depends upon the existence. Depends upon the extent of overlapping. The greater the overlapping, the greater the overlapping, stronger is the bond. Stronger is the bond. Okay. The valence orbitals of the element. The valence orbital of the elements. The valence orbitals of the element undergo proper hybridization before bond formation. Before bond formation, structure of the molecule are determined. Structure of the molecule determined. Structure of the molecule determined by the type of hybridization. Okay. The strength of the bond depends upon the existence of overlapping. The greater the overlapping, the stronger is the bond. Okay. The valence orbitals of the element undergo proper hybridization before bond formation. Before bond formation, structure of the molecule determined by the types of hybridization. Okay. 7 point. Point number 7. Okay. As a result of overlapping, and therefore pairing, electrons, energy is released, and thus the system acquires and state of lower energy is that high stability. Okay. As a result of overlapping, and therefore pairing of electrons. Energy is released, and thus the system acquires and state of lower energy, high stability. Is that high stability? Point 8. As S orbital is spherical symmetrical. As S orbital is spherical symmetrical. it has no conventional direction. It has no professional direction. Professional direction. It has no professional direction. Whereas P and D orbital whereas P and D orbitals have dumbbell. The orbitals have dumbbell and double dumbbell shape and double dumbbell shape. Okay. Hence they will tend to form. Bonds in the direction of maximum electron density within the orbital. Electron density within the orbital. Okay, orbital. As S orbital is spherical symmetrical, it has no preferential direction, whereas P and D orbital have dumbbell and double dumbbell shape. Hence, they will tend to form bond in the direction of maximum electron density within the orbital. Okay. Point number 9. Next point. Point 9. 9 number. Okay. 9 number. The existence of overlapping of two atomic orbitals is expressed as the extent of overlap of two atomic orbitals is expressed as S equal to integration of psi A into psi B dr. Okay, where S equal to overlap S equal to overlap comma psi A and psi B are wave functions for system A and B. For system A and B. Okay. When S is positive, bond will be formed. Bond will be formed. Attraction. Bond will be formed. Attraction. And S is negative. Is that repulsive takes place. Repulsive takes place. And S is 0, the existence overlap to our atomic orbital is expressed as, and overlap is 0, that means S is 0, then no interaction between combining atoms. Then no interaction between combining atoms. Okay. The existence of overlap of two atomic orbitals is expressed as S equal to integration of psi A into psi B dr. where S is overlap, comma psi A and psi B are wave functions for system A and B. When S is positive, bond will be formed attraction. Okay, bond will be formed and attraction. S is negative, then repulsive takes place. Then repulsive takes place or repulsion takes place. Okay. S is 0. If S is 0, that means overlapping is 0. No interaction between combining atom. No interaction between combining atom. Limitation of V.B.T. Limitation of V.B.T. Limitation of V.B.T. Valence bond theory. Valence bond theory. Valence bond theory. Valence bond theory. Okay. Limitations of V.B.T. valence bond theory. Valence bond theory. First point. Valence bond theory. Valence bond theory. Valence bond theory does not explain the existence of coordinates. The existence of coordinate bond in which electrons come from one atom only and not from one atom only and not from two different atoms. Atoms, okay? Valence bond theory does not explain the existence of a coordinate bond in which electrons comes from one atom only and not from two different atoms, okay? Second point. According to V.B.T. Valence bond theory, the oxygen atom in O2, the oxygen atom in O2, atoms in O2, molecule are bonded by a double bond, as O double bond O, okay? Oxygen double bond oxygen, and should be diamagnetic and should be diamagnetic and should be diamagnetic as there is no unpaired electron, as there is no unpaired electron, but experimentally O2 is paramagnetic. O2 is paramagnetic, which cannot explain explained by this theory. Okay. According to valence bond theory, the oxygen atom in O2 molecule are bonded by a double bond, as oxygen double bond oxygen, and should be diamagnetic as there is no unpaired electrons. Okay. According to V.B.T, the oxygen atom in O2 molecules are bonded by a double bond, as oxygen double bond oxygen, and should be diamagnetic as there is no unpaired electrons, but experimentally O2 is paramagnetic. O2 is paramagnetic. O2 is paramagnetic, which cannot be explained by this theory. Paramagnetic, which cannot be explained by this theory. Third point. This theory does not explain the formation of this theory does not explain this theory does not explain the formation of explain the formation of odd electron molecules like H2 cation, helium 2 cation, etc. Okay? Fourth point. This theory explains the formation and shape of simple molecules. This theory explain the formation and shape of simple molecules. Formation and shape of simple molecules, but it fails in the explanation. Explanation of the geometry explanation of the geometry and shapes of the complex compounds. Okay. This theory explains the formation and the shape of simple molecules, but it fails the explanation of the geometry and the shapes of the complex compounds. Okay. Fifth point. It also fails to explain the existence of perbromate. It also fails to explain the existence of perbromate. Okay. It also fails to explain the existence of perbromate.